So today we're looking at the binomial theorem. So we're just going to start with some examples here and work our way through them, see how we do. So example 1, we're asked to expand this thing and then identify patterns in the expansion. Now, in order to expand this thing, I don't want to do all the work by actually writing it out p plus q times p plus q times p plus q 6 times, because it's going to take a really long time. So we're going to take advantage of something called Pascal's triangle. Now, Pascal's triangle tells us all of the coefficients of all of our terms in our expansion. So, okay. Now, any expansion is going to have n plus 1 terms where this number is n. So the expansion of p plus q to the 6th is going to have 7 terms in it. So we would have to look down to whichever row has 7 terms in it. And it's row 6. So the row number will tell you it will be the same as n, and it will tell you which terms you should use here, which coefficients we're going to use. So we don't really know what's going on with the p and the q yet, but we can use Pascal's triangle to figure out what all the coefficients are. So the coefficients will be 1, and then p to the something, and q to the something. Okay? The next one, then we go 6, 15, 20, 15, 6, 1. 6p to the something, q to the something. 15p to the something, q to the something. 20p to the something, p to the something, q to the something. And then 15, 6, and 1. So 15p to the something, q to the something, 6p to the something, q to the something. Holy, still don't have enough room. Alright. And then finally 1, p to the something, q to the something. Now, notice we have 1, 2, 3, 4, 5, 6, 7 terms in here. If we multiply this p by itself all 6 times, we are going to get p to the 6. Now, in the leading term, this q won't have been multiplied in any of these terms, so it will actually be q to the 0. And as we move down, you'll see a little pattern. The second one is p to the 5 and q to the 1. Then p to the 4, q to the 2, p to the 3, q to the 3. So A, we're noticing that this drops by 1 every time. B, we're noticing that this gains 1 every time. And C, we're noticing that the sum of these two exponents is always the original exponent in our that we were expanding. So then this is 2, and this is 4, and this is p to the 1, and this is q to the 5, and then finally we have p to the 0 and q to the 6, which makes sense because q will be the last term, and multiplied by the last term through all 6 would give you q to the 6, and the p's would not make an appearance at all in there. So if we clean this up a bit, it's p to the 6 plus 6p to the 5q plus 15p to the 4q squared plus 20p to the 3q to the 3 plus 15p squared q to the 4 plus 6p q to the 5 plus q to the 6. Okay, that would have taken us a long time, if we had tried to expand it by repeatedly multiplying p to the q times itself, because we would have had to collect all of these like terms to turn them into these. So even if that seemed like it took a long time, it saved us a lot of time. So this brings us to the actual binomial theorem. Now, if you notice anything about the pattern in Pascal's triangle, these can also be done with combinations. So we have some experience with combinations, and if you notice these numbers, so let's say we're in row 6 and our original exponent was a 6. So let's take a look at the rule. This is on the formula sheet that the departmental supplies for your exam. So if we have a plus b to the n, so we had p plus q, same thing, doesn't matter, and our exponent was 6. Now our coefficients can be found by nc, and then starting at 0, then nc1, nc2, nc3, all the way to ncn, which in our case would be 6c6. Now let's take a quick look. Let's find a calculator. R is 0, but R being 0 is okay because actually this would just be 6 minus 0 factorial, and this would be 0 factorial, which is 1. So this would be 6 factorial over 6 factorial, which just gives us a value of 1, and we already know that our lead coefficient is 1. So let's take a look at the next one. Now it should be 6c1, and as expected we get a value of 6. Okay, so we know that we were supposed to get a value of 6. So the next few should be 15, 20, 15, 6, and 1. So let's take a look. So the next one would be 6c2. So there you go, 15. 6c3 would be 20. 6c4 drops back down to 15. 6c5 is 6. And finally, 6c6 is 1. So you notice that these coefficients follow that pattern where you start at 6c0, or you start at nc0, and move on from there until you're at ncn, which would be 6c6. And that's a good way to find all of your coefficients. Now, one more pattern that I want to point out in Pascal's triangle is any number in the next row can be found by the sum of the two numbers above it. So 2 is the sum of 1 and 1. 3 is the sum of 1 and 2. 3 is the sum of 2 and 1 here. So this will work for all numbers in Pascal's triangle. So 1 plus 3 is 4. 3 plus 3 is 6. 1 plus 3 is 4 again. So you keep going down and down and down. 6 plus 15 is 21. 15 and 20 is 35. So if you wanted, you could do the next row. We go 1, and then 1 plus 7 would be 8. And you would also notice the pattern here, 1, 2, 3, 4, 5, 6, 7, 8, keeps going up by 1s. So then 1 and 7 is 8. 7 and 21 is 28. 21 and 35 is 56. 35 and 35 is 70. 21 and 35 is 56. 21 and 7 is 28. 7 and 1 is 8. And then finally 1 at the end again. So that is Pascal's triangle and a brief introduction to the binomial theorem. So let's go on and try a couple more. I'm going to get you to attempt the your turn on page 539. Sorry I didn't have the energy to type it out, but I did put the answers here. So hit pause, come back and see the answers. There they are. Okay, so the your turn is done. So let's move on to the next part here. So example 2, use the binomial theorem to expand this. So all raised to the power of 4. So when it's raised to the power of 4, we know there are going to be 5 terms. And again, let's take a look at our binomial expansion formula here. And we could use combinations, or we could use Pascal's triangle, which is probably a little bit easier, but it doesn't matter. So a plus b to the n So we take whatever n is, and that's where our combinations start. That's also where the power starts on our first term. So go back to our example here, and we have 2a as our first term. So our first combination is going to be 4c0, which of course is just 1. And we are going to have 2a to the fourth, and the minus 3b will not appear at all in the first term. Now the second term is going to be 4c1, which of course is just 4. So we have the coefficient 4, and then we'll have 2a to the third power and negative 3b to the 1. So we can continue on like this, and we know we're going to end up with 5 terms. So the third term is going to be, let's look at Pascal's triangle. So when n is 4, we use row 4, and the third term will be coefficient of 6. Then we go back down to 4 and 1. So the third term is going to have the coefficient 6, and we could double check this as well by doing, this is 4c0, 4c1, 4c2, and if we go to our handy calculator, we can just plug in 4. I said we could plug in 4, C2, and you notice that we get 6. Okay, so that helps us confirm it. So our coefficient here then is 6, and we're going to have 2a to the 2, and now minus 3b to the 2 as well. Then we go back down to 4, and it will be 2a to the 1, and minus 3b all cubed, and then our final term will be a coefficient of 1, and there will be no 2a, so 2a to the 0 would be 1, and then it'll be just minus 3b to the power of 4. And then we would simplify all these. So 2a to the 4, well 2 to the 4 is 2, 4, 8, 16, so this is 16a to the 4th. Now this one, 2, 4, 8 times 4 is 32, and then we multiply that by minus 3. So then this coefficient will be negative 96, and you'll notice that every time the negative number has an odd power, we're going to end up with a negative coefficient, and that it will flip-flop from one to the next. So negative 96 is our coefficient, and then a cubed and b to the power of 1. The next one will be positive. 2a squared is 2a all squared is 4 times a squared. So 4 times 6 is 24. 24 times negative 9, or sorry, positive 9 now. 24 times 9 is 216. So 216 is going to be our coefficient here now, and a will be squared and b will be squared. Now we know the next one's going to be negative, so let's figure out what's going on here. 2a to the power of 1, so that's just 2a. So this becomes 8a, and now we do 8 times negative 27. So 8 times 27, and that is negative 216. And this will be a b cubed. And then finally, our very final term here, negative 3 to the 4. So negative 3 to the 4 is 81, and b to the 4 is, well, b to the 4. And we're done. Okay? So that's a. What is the third term in the expansion of this? So we can take a shortcut. We don't need to expand this whole thing out. We just want to know the third term. Okay, so this power gives us all the information we need to know. And actually there's a formula that the ministry puts on your formula sheet that can help you find the term. So the rth term, so we're looking for the third term, so r is 3, is combination of n and r minus 1. So this will be nc2, not 3. We're looking for the third term, so r minus 1 is 2. So nc2, and then we take n minus 2 and r minus 1. So n is 6 and r is of course 3. 6 minus 2 would be 4, and then 3 minus 1 would be 2, so we have 4 and 2, and we know that those add up to the 6 that we expect. So what did we say this was? This is nc2. Another way we could figure out what nc2 is, so this is 6c2 for the third term, is we take this 6 and we go back and we look at Pascal's triangle, and we look at the 6th row, and we look at the third term, 15. So that would be 6c2, and we can verify that that's true with our combinations calculator. 6c2, and there you go, 15. So we know we're doing things well. So 6c2 is 15. So the third term is going to be coefficient of 15, but we're going to multiply 4b to some power, and we decided that for term 3, for term 1 this would be power of 6, for term 2 it would be power of 5, for term 3 it would be power of 4, so that's another way to do it. And since they always have to add up to 2, or to 6 here, sorry, this one will be 2, and this will be the third term of our expansion. So 4, 16, 64, 256. So we have 15 times 256b to the 4 minus 5 squared is 25. And then we have to combine all these together, so we go 15 times 256 times 25 equals, and we get 96,000 b to the 4. And we're done. So the last one, which term in this contains just a when simplified? What is the value of the term? So we want just a. So we want a squared to the something, we don't know, let's just call it x. So a squared to the x times 1 over a to the y, and we want this to just be a. So we want one more here in the numerator, that's a y, not a 4, one more in the numerator than the denominator, so that this will cancel into just leaving us with an a. So how do we do that? And we know that these must always add up to 5. So we could try them all. We could try a squared to the 5 times 1 over a to the 0, but that's just 1. We know that that's not going to work out. So we could try a squared to the 4 and 1 over a to the 1, but we get the distinct feeling that that's not going to work out either. So we could try 3 and 2. You'll find out that we get a to the 6 over a squared. So that still won't work out for us. So let's try flipping those two and try the next one. So let's do a squared squared and 1 over a to the 3. And we get a to the 4th times 1, or something like it, 1 over a cubed. Now if we multiply these things together, we're going to be left with just an a. Now, which term does this happen in? Well, the value here is 2. It would have started at 5. So 5 for the exponent is the first term. That's the second term. That's the third term. This is the fourth term on this one. So it happens in term 4. Now it asks us to find the value of this term. So we want to find the value of term 4. And we can do that very quickly using our binomial theorem shortcut. So we want to find the value of term 4. So let's go look at Pascal's triangle. So our exponent was 5, so we're looking at row 5. Term 4, 1, 2, 3, 4. Our coefficient is going to be 10. So our coefficient is 10, and then we are going to have a squared to the 2, and we are going to have negative 1 over a to the 3. So 10 a to the 4th times negative 1 over a cubed, which of course is going to simplify to negative 10a. And that's it. We're done. So there's another your turn in the textbook. You can go ahead and try it, and it is after example 2 on page 541, and we can discuss the answers tomorrow in class. So have a good night. See you tomorrow.